Okay, so as I said already in the previous video, there will be no assignments from chapter 12, but we will be solving one problem, and we'll be solving chapter number 6. Uh, but before that, when I say no assignment, I'm not saying you guys shouldn't go and practice a few problems at least. It's just that you guys don't have to submit it. But as you should have already figured out, this is a very important chapter. So make sure that you do practice a few problems from the book, because you can expect a problem from this chapter in the final exam. Okay, so question number 6, we have a production function that's given by this is the functional form, and we also know that savings is equal to 20%. So small s is equal to 0.20. Depreciation rate, so delta is 10%, so 0.10. Labor force grow by 1% each year, so GN is 0.01. And technological progress is 6% per year, so GA is 0.06. These are the information that we have been given, and we have to calculate. Let's start with A1, steady state level of capital per effective worker. So capital per effective worker, which is K divided by AN, and we have to calculate the steady state level. So remember, for capital, what we want is investment equal to depreciation and all. So for this chapter, we saw that that relationship is given by, if I remember, SY by AN equals to delta K AN plus GA plus GN divided by K AN. Or we can just simplify and write this as SY, small y, equals to delta small k, GA plus GN times K, small k. We've already seen this in the video lectures. So this gives us SY equals to, oh sorry, we have a plus here. So if we take K common, we have delta plus GA plus GN. So another thing we have to do, of course, is we have to convert this in terms of per effective worker. So right now we have Y equals to KAN. So if we convert this into per effective worker, we have Y by AN equals to K by AN, A by AN, AN by AN, sorry. So what we get is Y is equal to small k times 1. Was that it? Oh, we have a 2 here. Sorry. So a 2, 2. So what we see is that Y is equal to 2 capital 2 root small k. So now we can apply this formula then. We know S is 0.2 times Y is 2 root k. This is equal to K times delta is 0.1 plus GA is 0.06, GN is 0.01. So if we simplify this a little bit, what we are going to get is 0.4 k to the power half equals to 0.17 k, or what we get is k to the power half equals to 0.4 divided by 0.17, or k is equals to 0.4 0.17 squared. I'm just going to use the calculator to figure out how much this is. It 5.5363. We don't need to go all the way to 4 decimal places. I think I'll just write this as 5.54. So this is our steady state level of capital. Part 2, we have to calculate the steady state level of output per effective worker, so which is small y. We have already calculated this, but how much was this? Right here. So this is equal to 2 square root k. Now we know that at the steady state, k is 5.54. So what we are going to get, once again, I'll need my calculator. Square root, I'm going to get 4.71. We have found the steady state level of capital per effective worker and the steady state level of output per effective worker. Let's move on to part 3. Part 3 is the growth rate of output per effective worker. Okay, so output per effective worker is, of course, you guys know, y divided by an, and we have to calculate growth rate of this. So let's call that g y a. How much is this? Now, what we already know is that in the steady state, output per effective worker is not going to be increasing. Total output will be increasing. Output per worker will be increasing, of course, but output per effective worker will not increase. That is what steady state means, that the economy has reached a sort of an equilibrium from which it's not going to be deviating. So output per effective worker, we don't need to do any calculation. This is just a theory. Part 4 is more interesting. Growth rate of output per worker. Right. Now, output per worker. Notice this is not output per effective worker. Output per worker. How much will this be? This, once again, this will be 6%. Or we can write 0.06. Why? Because technology is growing at 6%. So each worker working at the same level, using the same capital, is going to be able to produce 6% more every year because technology is growing at 6% every year. So that's just a theory. And part 4, we have to find growth rate of output. So growth rate of output, total output. How much will output grow by? Now we know that output per effective worker is not growing, but output per worker is growing, and total output is going to be growing at 6% for technology plus 1% for the population, which is 0.07, or you can call this 7%. Okay, I'm going to, calculation wise, this is quite straightforward. I'm going to spend a little bit of time talking about this three, because this is very important for you guys to understand. At the steady state, okay, at the steady state. By steady state, we mean that something has stabilized. That thing is not going to be changing. So what is steady state? What is stable in the chapter 12 model? That is output per effective worker and capital per effective worker. Okay, those looks horrible. Let me just rewrite. No, that looks horrible as well. Output per effective worker and capital per effective worker. Okay, these ratios are not going to be changing. That's what our steady state is. In chapter 11, what was steady was output per worker and capital per worker. Okay, and this is chapter 12. So these ratios are not going to be changing. However, in chapter 11, since we assumed that n was fixed, to keep these ratios equal, y had to be fixed as well. K had to be fixed as well. Because if n is fixed, if there is no growth in population, to keep these ratios fixed, y and k could not change. Okay, let's get rid of this now. In chapter 12, what we have done is we've said that A, population, is going to be growing, and N, technology, is also going to be growing. I mean, growing in our example, it can be decreasing as well, but they will be changing. Now, let's just focus on one of them. Output per effective worker. This ratio has to stay constant. That is the steady state. That means that if just n is going up, keep the ratio constant, y has to grow as well. Similarly, if a is going up, y has to change as well. That is why, let me get rid of this markings. That is why what we can say is that if just a is growing, so if just a is growing, then the ratio y by n, which is output per worker, has to grow to keep the ratio simple. That is what we have calculated in part 4. Y by n, see, y by n. And we calculated that y by n had to be growing because a is increasing. And in part 5, what we have done is we've allowed both a and, oh, what did I do? We have allowed both a and n to change. And when a and n is changing, to keep the ratio constant, y has to grow. And that is what we've done in part 5. Okay. So I hope this is clear to everyone now. If it isn't clear, it will help to do this entire thing on your own. I'm going to move on to part B, but if that the explanation, the concept, the ideas are not clear to you guys, please just do it on your own. And it's not that difficult to understand, you will see. Okay. Part B, something has changed. Labor force now grows at 5%. Okay. So GN used to be 0.01. From here, it's become 0.05. Okay. And based on this, we have to calculate everything we've done already. Okay. So steady state level of capital. So we do the same thing again. So S times Y is equal to K delta plus GA plus GN. So S we know is, S has not changed, still 20%, times Y was 2 times square root K, if I'm not mistaken. Let me just check. Y was 2 square root K, yes. This is equal to K times depreciation has not changed, still 10%, plus GA has not changed, it's still 6%. GN has changed from 1%, it's now 5%. So that means what we get is 0.4 k to the power half equals to, from the bracket we get 0.21 k. So k to the power half is equal to 0.4 divided by 0.21, and so k star is 0.4 divided by 0.21 square. And once again, I'll go to my calculator. Gives us 3.63. That's part A. Part B, we have to calculate y, which is equal to 2 times 3.63. So that will give me 3.81. Part 3, we have to calculate growth of effective output per effective worker, small g. As we've talked about before, this is of course 0 because this is not growing at the steady state. However, output per worker is growing at the rate at which technology is growing. So same thing, 6%. And output, just growth of output is growing at 6% plus 5%, which is 11%. So in part B, we have to calculate the two things. Okay, so let's write this down. A and B. So we've calculated K star, calculated Y star, calculated G of effective worker, output per effective worker, this and this. Okay. So of course, this is 0, 0. This is 6% in both cases. And this was how much? 7%. Doesn't look like 7%, 11%. K, we have, this is 3.81 and 3.63. And in part A, we had calculated this as 5.54, 4.71. Okay, so we're going to analyze this. Remember, the change that has happened between A and B is that labor force now grows faster, or let's call it population to make the explanation simpler. Population growth rate has increased. Okay. As a result, these are the things that has happened. Okay. Why will that be? That should be pretty obvious. Since population grow at a faster rate now, what we are going to see is that each worker is going to have less capital to work with. As a result, each worker has less capital work with. Since each worker has less capital to work with, that also means that each effective worker, that also means that each effective worker, you have less capital, so each effective worker produces less output. If you don't have enough capital, you're going to be producing less. And we see both of that. Uh, Capital per effective worker has fallen. Output per effective worker has fallen. Okay. Now let's come to the growths. We know that this is just what happens at the steady state. So this is 0 in both cases. What you can say, okay, I'll write this down in green, is 0 at the steady state. But what you should realize is that the economy won't just always be at the steady state. So the scenario we had at A is a steady state. Then growth rate of population goes up. As a result, we move, or the economy moves, we move to point B. But this is not instantaneous. Remember what we had seen when we have this, and suppose we are at this point, and then something changes and we're going to end up at this point. We don't move there instantaneously, do we? There is a transmission mechanism. We move there gradually. For example, just take a look at this problem that we had solved. See, we looked at year 1, then year 2, then year 3. There was a transmission over time. Over time, we moved from A to B. So similarly, we're going to move from A to B, or actually it's the other way around. Capital and Y is falling. So we're going to move from A to B in this way. But that won't be instantaneous. That will take some time. Okay. So Gn, as a result, we move to B over a period of time, during which growth of output per effective worker will change. Of course, it will change because you see that growth output per effective worker is changing from 4.7 to 3.8. It will change. But once we get to the steady state level, it's at 3.81 and it will no longer change. Okay, that's the takeaway. Next part, what happens to this growth? G. So output per worker, growth of output per worker is driven by technology. There is no change. Technology. Therefore, growth of output per worker does not change. Once again, this should be pretty straightforward to everyone else. And now we're looking at growth rate of output. And what we see, this is the interesting part. This is interest. Why will that be? Why is our output growing at a faster rate? Because remember what the steady state implied. The steady state says that output per effective worker will not change. Population is growing faster, but output from each of this worker cannot change. That's the steady state. As a result, since we have more worker, each of them will be producing something, and so our output has to go up. Since uh, since growth of workers is faster, output of the economy grows at a faster rate. Of course, I've written this down very quickly, very curtly. You guys should explain a bit more during exams, but effectively, this is it. This was part B. Now, I think there is a part C as well. Okay, what has happened in part C is that growth of population remains at 5%, but for some issue, growth of technology, which used to be 6%, falls to only 2%. So now you guys have to calculate what happens as a result. So exactly the same thing that we've done in part B. We've done A, we've done B, you guys do C. Okay. So this is one practice problem that you guys can do from this chapter. All right. So that's it for chapter 12. In the next videos, we will be starting chapter 13, which should be the most interesting chapter of the syllabus.